In section 3.4, the objective is to be able to use slope to determine if two lines are parallel, perpendicular, or neither. What is slope? You should remember from Algebra 1 that slope means rate of change, and there are many ways to express slope. We could call slope rise over run. We could call slope change in y over change in x. That's what the delta, that Greek letter delta means. It means change. In fact, you can write that with words, change in y over change in x, but the delta is just a faster way to write it. You can use the slope formula to express it. So the change in y, a change between values, is the difference between them, y2 minus y1 over x2 minus x1. Many ways to represent slope being rate of change. Out in the real world, we use slope for many different things. For example, think about driving up a hill. For every inch that you drive, you increase your altitude some. When else in life do you experience slope? Write an example on your notes of where you find slope outside of the math classroom. Let's do an example of finding the slope of a line containing 2 points. First of all, point C has an x and a y coordinate. Because this is the first point I encounter, I'm going to label this x1 and y1. Point D also has an x and y coordinate. I'm going to label those x2 and y2. And if I have to find the slope, I'm going to use the slope formula since I don't have a graph to look at. So here's how I write what the slope is. M is our letter for slope. Let's go ahead and write that up here too. M is what we usually use for slope. Notice it's a lowercase m, not to be confused with an uppercase M that we use for midpoint. It is not the uppercase M, it is the lowercase m. So the slope, now what line am I taking the slope of? The line that connects points C and D. So as a subscript, I'm going to write CD. The slope of line CD equals, now I'm going to remember my slope formula. I'm taking y2 minus y1. So 2 minus negative 3. And I'm dividing by the change in x. x2 minus x1. Negative 4 minus 1. And then I can simplify that. 2 minus negative 3 makes 2 plus 3, 5. Negative 4 minus 1, negative 5. This can be simplified, so I do that. 5 divided by negative 5 is negative 1. And there's my slope. Now, if we merely have a horizontal or a vertical line, those slopes we don't have to calculate rise over run. If we have a horizontal line, the slope is 0. What does a horizontal line look like? Well, let's take an example that might be like this. Horizontal, side to side. The slope is 0 because there's 0 rise, but any number of run. Let's say this is going through the y-axis at the coordinate 0, 3. So the y-coordinate is 3. The equation for this line would be y equals 3. A vertical line looks like this. Vertical lines cross through the x-axis. Let's say this is crossing through at about 4. So this equation would be x equals 4 because it's crossing through the x-axis. Again, we don't need to calculate a rise over run. Here, the rise is infinite, but there is 0 run. So for a vertical line, the slope is undefined. Some people use the memory trick called Hoy-Vux. Ever heard of it? Hoy-Vux. How is this helpful? Well, let's look at the letters. H for horizontal. Think a horizontal line going side to side. 0 is the slope. So our slope is 0. 0 is the slope. And the equation is y equals. See, y equals. That's the equation. Vux, well, because a vertical line v. U for the slope is undefined, so the slope. And then for the equation, x is how we write it. It crosses the x-axis, x equals 4. So if you remember hoi vux, that could be a memory trick to help you with some of those. Let's talk specifically about parallel and perpendicular lines. Parallel lines have the same slope because they go in the same direction. So parallel lines have the same slope. Perpendicular lines do not have the same slope. Perpendicular lines, now remember how they look. Parallel lines go in the same direction, so same slope. Perpendicular lines don't go in the same direction, but they have to go in specific directions where they create a right angle at their intersection. They have slopes that are opposite reciprocals. Slopes are opposite reciprocals. So what does that look like? For example, the slope of one line might be 2/5. The slope of the other line might be negative, that's the opposite, 5/2. That's the reciprocal, upside down. Another way to think of what the slopes are supposed to be is if I take these two slopes and I multiply them. 2/5 times -5/2, they're supposed to make -1 when we multiply the slopes. So the product is always -1. The product, when we multiply the slopes of perpendicular lines, we get -1. Now remember the symbols for parallel and perpendicular. These are great to know because then it gives you a shortcut for writing the words parallel, looks like this, a double L, like in the word parallel. Perpendicular looks like this, kind of like an upside down T, like two perpendicular lines. Let's do a couple of examples where we have to determine, using slope, if the lines are parallel, perpendicular, or neither. So we're going to calculate each slope. This one says line 1, and these are the two slopes, or the 2 points, excuse me, on line 1. So I'm going to write slope 1 equals, and then I'm going to look at these x1, y1, x2, y2. And maybe I write down my slope formula as a reminder. y2 minus y1 over x2 minus x1. So my y's, I'm going to start with those. 4 minus 0 over my x's. If I started with the second point, I start with the second point again. So it looks like 4/6, but we can simplify that to 2/3. We always leave slope as a simplified fraction, never a decimal, because that way we can see the rise and the run for when we have to go and graph it. Let's do line 2. Slope of line 2. So again, x1, y1, x2, y2. So take my y's first, 6 minus 0, and 3 minus 7. 6 over -4 simplifies to negative. Notice how I'm not leaving the negative in the denominator, 3/2. So let's take a look at these slopes. 2/3, -3/2. Notice how positive, negative. Notice how 2/3 got flipped over to 3/2. These are opposite reciprocals. We can check by multiplying 2/3 times -3/2, and I get -1 when I multiply. That tells me the lines are perpendicular. So I answer perpendicular, and I'm going to do it with the symbol perpendicular, and that's my final answer for number 2. Why don't you pause the video and try number 3 and come back and check how you did. So how did you do? -2 for the first slope, -2 for the second slope, same slope, therefore our lines are parallel. Did you get it? We're going to continue to find slope and determine parallel or perpendicular, but now using graphs. So let's take a look at these two lines, line A and line B. See the labels on them? Now I'm not given points this time, so I may want to think in terms of rise over run. Remember that slope can also be thought of graphically. rise over run. So I might want to find exactly where these lines cross through grid points. And I see maybe here's a point and here's another point on line B. If I'm looking at line A, I notice here's a point and here's another point on line A. I usually try to pick the points that are closest together as possible. So now I'm going to count my rise over run. So I'm going to say slope of line A. Now the A is a subscript. Notice lowercase letters for lines. So starting from here, I count down 1. Now that's important. I go down because that means negative. Then I go to the right 1, so over 1. I can simplify that. Negative 1 divided by 1 is negative 1. Now let's count for the slope of line B. From left to right, I go up 1 and then over 1. So the slope of line B is positive 1 over 1, which makes positive 1. So what do we think about these slopes? Well, if I multiply them together, negative 1 times 1 makes negative 1. And when I multiply and I get negative 1, remember what that means? Perpendicular. These lines are perpendicular. Now, don't always assume from the graph that it's going to be perpendicular or parallel. Sometimes the graph can be deceiving. For example, in number 5, notice how these two lines, they look like they're never going to intersect. However, when we count the slope, we see something different. Why don't you pause the video, count the slopes, come back, and see how you did. So let's see how you did. The slope for line C. I picked these 2 points, 2 close points. From left to right, I counted down 3 blocks and over 2. So there's my slope for line C. For line D, I counted down 2 blocks and over 1. So negative 2 over 1, which makes negative 2. Remember that for lines to be parallel, they have to have the same slope. These are pretty close, but they're not the same. Therefore, these are neither parallel nor perpendicular. So make sure you're not deceived by the graph and that you actually do the work to count the slopes. Let's see what other ways we can use slope to help us through some problems. Graph a line parallel to the given line through the point provided. So from this point, we want to graph a line that's parallel to this line. So remember when we see the word parallel, we want to think same slope. So what do you think we need to do first? That's right, find the slope of this line. So let's find the slope of this one line that we have. It's not labeled because it doesn't need to be distinguished from a different line. So let's go ahead and find 2 points that are pretty close together. So it looks like I could pick this point here and this point here. And if I count the rise over run, I'm going down 1 and over 2. So the slope is negative 1 over 2. Now keep in mind, if you pick points that are farther apart, you're just going to reduce or simplify your fraction to negative 1 over 2. So if we need the same slope, we're going to count the same using this point. Remember, it says through the point. So I'm going to start at my point and I'm going to do the same thing I did here. Go down 1 and over 2. And that'll give me a new point. Now it looks like I've run out of room going this way, so I'm going to make sure I get enough points and do my slope backwards. So if it was down 1 and over 2, then I'm just going to have to go over 2 and up 1. Over 2 and up 1. Always plot as many points as you can to get a nice straight line when you connect them. Now we can grab our straight edge and connect the points. Remember to show arrows at the ends of your line to show that it's going on forever. Would you like to try the next one? Pause the video, come back and check your work. So I hope you didn't get fooled by this. This says graph a line perpendicular this time to the given line through the point provided. So we still need to think about the slope, but this time not the same slope. We want to think opposite reciprocal slope. opposite reciprocal slope. So still, we have to count the slope first. So let's find 2 points that are pretty close together, maybe this point here and this point here, and count the rise over run. 1, 2, 3, 4, and 1. So 4 over 1. Now I can write that as just 4, but if I have to do the opposite reciprocal, it's going to help me more to think of it as 4 over 1. So now I want to think the slope for my perpendicular line. So I'm going to say the slope for the perpendicular has to be flipped over, 1 over 4, and the opposite sign, so negative. So starting at this point provided, I'm going to do down 1, and then 1, 2, 3, 4 over 4. And there's another point. Let's do it again. Down 1 and 1, 2, 3, 4. And I've got a variety of points. So now I can use my straight edge to connect my points. Make sure I put arrows at the end.